2559C asks us to, again, take propylbenzene and synthesize this molecule. It's important to think about where propylbenzene shows up in the structure because it gives us a little bit of a hint about what types of reactions might get us into the final structure. So propylbenzene is going to be a chain of 3 carbons off of this benzene. So either 1, 2, 3, or 1, 2, 3, or 1, 2, 3. The thing that I thought was probably easiest to envision is having this react like this. If we have the propylbenzene as it's shown, then we can actually take this and react it with this piece via a Diels-Alder reaction. If this is the diene, this 4-carbon piece makes up a diene, we'd have the explanation for the double bond back here, and all we need is a dienophile, probably an alkene, on this position. We can think about this a couple of different ways, but probably the easiest way is to think about taking the propylbenzene, reacting with Br2 in light, just like we've done in pretty much all these other examples. We end up with a bromine on this position, and now we can go through an E2 substitution or elimination reaction with some sort of strong base. I'm going to use tert butoxide because I know if I use something big and steric like that, there's no chance of substitution. And we end up with a double bond on this position. We'll primarily form the trans bond here, which is actually kind of a problem because we see, well, it could be a problem. It doesn't actually give stereochemistry here. Never mind, it's not actually a problem. This is fine. Everything's fine. So we can use the trans. If we needed it to be cis, then we'd have to use an alkyne, and so we'd have to increase this to an alkyne by reacting with Br2 and then double eliminating again. But since your textbook doesn't actually designate chirality here, then we're actually just fine. And all we really need to do is react with a diene, like this, butadiene. So if we do that in the presence of heat, we'll go through a Diels-Alder reaction. We'll end up having these electrons kick up to make a new bond here. These kick back, these kick down to here, and we will form a new 6-membered ring exactly like this. Now, there is some amount of complication here because this is actually a donating group, and it's uncommon to actually have donating groups on the dienophile. Usually we have electron withdrawing groups. If we wanted to get around that, we could install a carbonyl at this position and then add it onto the diene and then use like a Clemmensen reduction or a Wolff-Kishner reduction in order to eliminate that afterwards. That would be a fine way of trying to activate this group if we otherwise didn't have it. That product is also readily available if we have a carbonyl on this position. That's cinnamaldehyde, and so that would be an easy way to do that reaction as well.